All right, again, we are here to talk about Maths 209. Maths 209. We want to talk about the E operator. The E operator. The E operator, Maths 209. So, and the E operator and relationships. The E operator, the E inverse operator, the E inverse operator, the forward difference operator, and the forward difference operator. This is the forward difference operator, and this is the backward difference operator. So this is the forward difference, this is the backward difference, the E inverse operator, and the E operator and the E inverse operator. All right. Okay. Let's look at something interesting together. So when we say E operator, what comes to our mind is that if a function y, let y equals f of x, be a function of x, x plus h, x plus 2h, right? Then the E of f of x. So when we say E of f of x, it says push that f of x just to the front. So we say E of f of x is f of x plus 2h, right? So if I say E f of x plus h, I'm just saying push this to the front. That's f of x plus 2h. Now let me explain. Remember when we said the forward difference of f of x, what comes to our mind? The forward difference of f of x is where we are going to, f of x plus h, minus where we are coming from, right? So when I now say this is a number line, this place represents f of x, this person represents f of x plus h, this person represents f of x plus 2h. So what I mean is E f of x means push this person to the front, just stay here, that's all. If I say E f of x, that means I'm here, push this person to the front, that's f of x plus 2h. So just one movement, right? So if I say that E f of x plus 2h, what will my answer be? My answer will be f of x plus 3h. I'm just simply pushing this person to the front. Just push this man to the front. That is what it means. All right. So when I now tell you that there is a relationship between the forward difference operator and the E operator. There is a relationship. Should we establish the relationship? Yes. Let's establish the relationship between the forward difference operator and the E operator. Let's establish the relationship. All right. So we say that the forward difference, remember, of f of x is equal to, let's clean this. The forward difference of f of x is f of x plus h minus f of x, right? Right. Now, we now remember that E f of x is f of x plus h alone. So, E f of x means pushing f of x to the next person. Remember, if this is f of x, this is f of x plus h, this is f of x plus 2h. So if I'm at this junction, f of x, and I say E f of x, it means push this person to the next person, f of x plus h. If I'm at this junction and I say E of this person, push it to the next person. So if I say E f of x, what I actually mean is f of x plus h. So is it possible for me to translate this and say the forward difference of f of x is equal to So this person is now being utilized for this person. Did you see that? So anywhere I am seeing f of x plus h, I'm just going to be writing e f of x. So I'm saying e f of x minus f of x. Did you see that? Did you see that? So at the same time, we can now factorize and say e f of x, for the difference of f of x plus h, is f of x into the bracket of e minus 1. And so we can divide through by f of x. Divide through by f of x. And so when you divide through by f of x, let's clean this. When you divide through by f of x, the forward difference will be e minus 1. Did you see that? This is the relationship between the forward difference operator, the forward difference operator, and the e operator. So you can be asked in a test question, they said, establish the relationship that exists between the forward difference operator and the e operator. Or you can simply say is that the what? That the forward difference operator is equal to e minus 1. And we have been able to establish that here. Did you see that? We have been able to establish that here. Alright? Now, having said this, there is something called the backward difference operator. There's something called the backward difference operator. The backward difference operator. Just like we have the forward difference. This is forward difference. This is backward. Let me call this BDO, backward difference operator, and FDO, forward difference operator. So, forward difference operator is, if I say forward difference of yn is yn plus 1 minus yn. I'm not wrong. So if I say let n be equals to 0, it means forward difference of y0 is equal to 0 plus 1 minus y0 itself. It means forward difference of y0 is y1 minus y0. I'm not wrong. That's correct. It's the same way. We have that the backward difference of yn is where we are right now, yn minus what is at our back. So if I say this is f of x, or if I say this is yn, this is yn plus 1, this is yn plus 2, this is yn minus 1, this is yn minus 2. So if I say we are at this junction, if I assume that we are at this junction, and I say what is the backward difference of yn? This junction. The backward difference of yn is where we are right now, yn, minus where we are, what is at our back? At our back. See that? Yn minus 1. Did you see that? Right? So it means that the backward difference of y1 is y1, right? y1 minus y0. Did you see that? The backward difference of y1 is where we are right now, the y1 itself, minus what is at the back, y0, which is also the same thing as the forward difference of y0, because the forward difference of y0 is where you are going to minus where you are coming from. Did you see that? So these are the things we need to watch and the things we need to notice when operating the difference operators. All right, now let us establish. Can I clean this part? Yes. Let us establish the relationship. Let's establish the relationship between the backward difference operator and the E inverse operator. So e to the power of minus 1 means E inverse. Alright? What is the relationship that exists between the backward difference operator and the E inverse? Now, remember, just as you said E of f of x means push this to the front, right? Push it to the front. It means that E inverse of f of x means push it to the back. So if the positive going front is plus h, going back will be minus h. So E inverse of f of x is f of x minus h. Are you clear on that? And so we now find out that the backward difference of f of x itself, the backward difference of f of x is where we are right now, f of x itself minus f of x minus h. Did you see that? The relationship that exists between the backward difference and the E inverse operator is that. So let's move forward from here. We have recall that E inverse of f of x is f of x minus h. So what I'm going to do here is to replace, did you see that? I want to replace this part of the function. I want to replace it with this. E inverse of f of x. E inverse of what? Of f of x. And so when I replace that with E inverse of f of x, what I'm going to have is the backward difference of f of x is equal to f of x minus, so I'm not going to be writing f of x minus h, I will be writing E inverse of f of x. Did you see that? And so if I factorize here, I'm having the backward difference of f of x is equal to what is common to both sides, f of x into the bracket of 1 minus E inverse. Did you see that? And so we can cancel out, f of x cancel out. So we have that what? We have the backward difference, is equal to 1 minus E inverse. This is the relationship that exists between the backward difference operator and the E inverse operator. This is a relationship that exists between them. Alright, so we've been able to establish the relationship that exists between the forward difference operator and the E operator. We said the forward difference operator is equal to 1 minus E. No, sorry. The forward difference operator, let's repeat that again. So this is clear, we are clear on this. Let's repeat the forward difference operator again. We said the forward difference of f of x is equal to f of x plus h minus f of x, right? And we said that E f of x is equal to f of x plus h. So we are just replacing this with this. So forward difference of f of x is E f of x minus f of x. So forward difference of f of x is equal to f of x into the bracket of E minus 1. So we cancel out. It means the forward difference is E minus 1. These are the relationships that exist between these operators. The backward difference operator is 1 minus E inverse. The forward difference operator is E minus 1. Alright? So I hope we are clear on that. See you in our next class in Maths 209. Again, this is Sir Rizzy. I am Sir Rizzy. If you have further questions, then you can chat me up on 090 5866 9385. Alright? Alright.